The perimeter of a figure is the total distance all the way around the outside of the figure. Any units involved are linear: inches, centimeters, feet. If a figure consists of straight line segments, examples are triangles, rectangles, parallelograms, trapezoids, then the perimeter is the sum of the lengths of all sides. For example, the perimeter of a rectangle with length L and width W is 2L plus 2W. There are two sides that have length L and two sides that have length W. There is no need to memorize this formula. The only formula that is not obvious is the perimeter of a circle. For circles, we call the perimeter also the circumference. And the formula for the circumference of a circle with radius r is 2 pi r. And here's a picture. Let's illustrate this with the examples on page 78. Find the perimeter of the following figures, assuming the sides of the little squares have length 1. Here's question 1. On this picture, we can immediately see that AB is 5. To find AC and BC, we will divide triangle ABC into two right triangles by drawing the perpendicular line to AB from C and use the Pythagorean theorem. So here's that picture. We use the Pythagorean theorem in triangle ACD to find AC. We get 2 squared plus 3 squared is AC squared. So AC is the square root of 2 squared plus 3 squared, which is the square root of 4 plus 9, which is the square root of 13. For BC, we use the triangle BCD. The Pythagorean theorem tells us 3 squared plus 3 squared is BC squared. So BC is the square root of 3 squared plus 3 squared, which is the square root of 9 plus 9, which is square root 18, which we can simplify because we can write 18 as 3 squared times 2. Rewriting the square root as the product of the square roots, we can simplify this to 3 square root 2. So what is the perimeter of triangle ACB? It's the side AC plus the side BC plus the side AB, so we get 5 plus square root 13 plus 3 times square root 2. Question 2. What is the perimeter of the following figure? We divide the figure into 3 pieces. And we can already find quite a bit of lengths or distances in this picture. The length AC is 8, the length ED is 5. The distance DC is 4, the distance EB is 4. Now, to find the perimeter of this figure, we will need to figure out what the length AE is. We can use the Pythagorean theorem in triangle ABE for that. And we also need to find out what the length of this circular arc DC is. For that, we use the formula for the circumference of a circle. So we have that BC is the same as DE is 5. The distance AB is AC minus BC, which is 8 minus 5, is equal to 3. We use the Pythagorean theorem to find AE. We have 3 squared plus 4 squared is AE squared. So AE is the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16, is the square root of 25, which is 5. The arc CD is a semicircle with radius 2, namely half of the diameter CD, which is 4. So using the formula for the circumference of a circle, we get that the arc CD will be 1/2 of the perimeter of a circle, which is 1/2 times 2 pi r. So here this becomes 1/2 times 2 pi times 2, which simplifies to 2 pi. Hence the perimeter of the whole figure is the side AC plus the circular arc CD plus the side DE plus the side EA, which is 8 plus 2 pi plus 5 plus 5, which simplifies to 18 plus 2 pi. And that is our final answer. For area, we mentioned the formulas for the area of the following figures: rectangles, triangles, parallelograms, trapezoids, and circles. Any units involved are square units: square inches, square centimeters, square miles, etc. The area of a rectangle is the length times the width. The area of a triangle is 1/2 times the base times the height. The area of a parallelogram is base times height. The area of a trapezoid is 1/2 times base 1 plus base 2 times the height. And the area of a circle is pi r squared, where r is the radius of the circle. Let's illustrate this with the examples on page 80. Find the area of the following figures. Here we divide this figure into 3 pieces. From left to right we will have a triangle, a rectangle, and a trapezoid. Here are those 3 figures with some distances. In order to find the area of triangle AFG, we need to know the base and the height. We can choose the base to be AF, which is 3 feet, and the height is then 2 feet. For a rectangle ABEF, we can choose the length to be 4 feet and the width to be 3 feet. For the trapezoid EBCD, we have that the bases are 3 feet and 6 feet and the height is 2 feet. So for triangle AFG, we view AF as the base. Then the area of the triangle is 1/2 times base times height, which is 1/2 times 3 times 2 square feet, which simplifies to 3 square feet. For rectangle ABEF, we can view AB as the length and BE as the width. Then the area of the rectangle ABEF is length times width, which is 4 times 3 square feet, which simplifies to 12 square feet. For the trapezoid BCDE, we have that the bases are CD and BE. So the area of trapezoid BCDE is 1/2 times base 1 plus base 2 times the height, which is 1/2 times 6 plus 3 times 2 square feet, which simplifies to 9 square feet. Hence the area of the figure is the sum of the 3 areas, 3 square feet plus 12 square feet plus 9 square feet, which is 24 square feet. Question 2. This figure here is a parallelogram. To find the area of a parallelogram, we need to know the base and the height. Here we can choose the base to be 5 inches. In order to find the height, we have to use the Pythagorean theorem in that little triangle where one of the legs is 2 inches and the hypotenuse is 4 inches. We get 2 squared plus h squared is 4 squared. So 4 plus h squared is 16. Hence h squared is 16 minus 4 is 12. And so h is the square root of 12, which we can simplify since 12 is 2 squared times 3. We can rewrite this as 2 square roots and simplify to 2 square root 3 inches. Hence the area of the parallelogram is base times height, which is 5 times 2 square root 3, which simplifies to 10 square root of 3 square inches. Question 3. What is the area of the following figure? The area of this figure is the area of the big rectangle, ABCD, minus the area of the semicircle. To find the area of a rectangle, we need the length and the width. We can choose the length to be 5 centimeters and the width to be 2 centimeters. To find the area of the semicircle, we need to know the radius. Here a diameter is 2 centimeters, so the radius will be 1 centimeter. The area of the rectangle ABCD is length times width, which is 5 times 2 square centimeters, so 10 square centimeters. Since EF is the diameter of the semicircle, we get that the radius is 1 centimeter, namely half of the diameter. So the area of a semicircle is half the area of a circle, which is 1/2 times pi r squared. In this case 1/2 pi times 1 squared, which simplifies to pi over 2 square centimeters. So the area of the figure is the area of the rectangle minus the area of the semicircle, which is 10 square centimeters minus pi over 2 square centimeters. Next, we are up for volumes. We mentioned the formulas for the volume of two shapes, rectangular solids and cylinders. Any units involved are cubic units, cubic inches, cubic centimeters, cubic miles, etc. For a rectangular solid, the volume is the length times the width times the height. For a cylinder, the volume is pi r squared h, where r is the radius of the cylinder and h is the height of the cylinder. Let's illustrate this with the examples on page 82. What is the volume of the following shape? Here we can divide the shape into two rectangular solids, the top piece and then the bottom piece. In order to find the volume of a rectangular solid, we need the length, the width, and the height. For the bottom solid, we can choose the length to be 10 feet, the width 8 feet, and the height to be 2 feet. For the top piece, we have 5 feet, 4 feet, and the height is a little bit more work. It is the height of the whole figure, 3 feet, minus the height of the bottom piece, 2 feet, so 1 foot. So here's a picture of those two pieces. For the bottom solid, we choose the length to be 10 feet, the width to be 8 feet, and the height to be 2 feet. Then the volume of this rectangular solid is length times width times height, which is 10 times 8 times 2 cubic feet, which is 160 cubic feet. For the top solid, we choose the length to be 5 feet, the width to be 4 feet, and the height to be 1 foot. So the volume of this rectangular solid is length times width times height, which is 5 times 4 times 1 cubic feet, so 20 cubic feet. Hence the volume of the whole shape is the sum of the volumes, 160 cubic feet plus 20 cubic feet, which is 180 cubic feet. Question 2. Find the radius of a cylinder given that its volume is 28 pi cubic centimeters and its height is 7 centimeters. Recall that the volume of a cylinder with radius r and height h is pi r squared times 8. So here it is given that the volume is 28 pi cubic centimeters. So 28 pi cubic centimeters must be equal to pi r squared times 7 centimeters. We can solve this for r squared by dividing both sides by pi times 7 centimeters. So r squared is 28 pi cubic centimeters divided by pi times 7 centimeters. This simplifies quite a bit. The pi cancels out, 28 over 7 simplifies to 4, and cubic centimeters over centimeter simplifies to square centimeters. Next we solve for r by taking the square root out of both sides. R is the square root of 4 square centimeters, which is 2 centimeters. The square root of 4 is 2, the square root of square centimeters is centimeters. So the radius of that cylinder is 2 centimeters.